In this set of notes, we're looking at finding the surface area and volume of triangular prisms. In the case of the problems that we'll be doing in class, we have three different types of triangular prisms that we'll be looking at. Triangular prisms that have a right triangle for a base, triangular prisms that have an isosceles triangle for a base, and triangular pyramids that have an equilateral triangle for its base. For that reason, and the way that we've got the examples split up here in the notes, I'm going to be dividing this into a series of 3 videos, one for each of these particular types of prisms. So in general, a triangular prism is a solid with 2 triangular bases that are parallel and congruent. The height of the prism is the perpendicular distance between the bases. The shape of the triangular base may be any type of triangle: acute, obtuse, right, scalene, isosceles, or equilateral. And as we've said, we are going to be focusing on these 3 particular types of triangular bases. In general, for all prisms, the surface area is equal to 2 times the area of the base plus the perimeter of the base times the height of the solid, and the volume is the area of the base times the height of the solid. So these are very familiar to us already. We'll just be using them in a different way. With that in mind, let's look at a couple of examples with right triangle bases. So the first thing we want to do, and what I'd suggest that you do, because I find that it works best for my students when they do this, is to draw the base by itself. Ignore the rest of the prism entirely. By resketching that base, you focus your attention on the base itself and can kind of disregard the other elements. So in this case, I have a right triangle, and on either side of that right angle, I have one leg that's 8 millimeters long, and the other leg is 12 millimeters long. Keeping in mind that this 15 is the distance between the triangular bases, so that will become our h value later when it comes to time to find the surface area and the volume. All right, so in terms of the area of a triangle, we know that we have to find the area of the base and the perimeter of the base. In order to find the area and perimeter, I need to know this third side in order to find its perimeter. And that's where your Pythagorean theorem is going to come into play. So leg squared plus leg squared, 8 squared plus 12 squared, equals that hypotenuse c squared. Now, in the case of solving this particular Pythagorean theorem, once we take 8 squared plus 12 squared, we get 208. And we know that's going to be equal to c squared. However, we need the length of the leg by itself, so c would be the square root of 208. It is not necessary to simplify that square root, nor do you want to turn it into a decimal at this point, because that's not your end result. Your end result will be to use that to find the perimeter of the polygon, and we'll use it to find the, no, we won't use it. We'll use it for the perimeter of the polygon. So, started to say something else, and turns out I was going the wrong direction with it. All right, so in this case, let's find the area of the base then. We need our capital B and our capital P values. The area of the base, 1/2 base times height. Remember, your lowercase b here is the length of one of the legs, and the other leg is the height. So in this case, 1/2 of 8 times 12. In that triangle, the lowercase b and the lowercase h should always be the 2 values that meet at the right angle. All right, so 1/2 of 8 is 4 times 12. 48, in this case millimeters squared. The perimeter of the base is found by adding all 3 sides together. So 8 plus 12 is 20. 20 plus the square root of 208, I'm not really sure what that is. It's going to be some decimal. I'm not really concerned with particularly what decimal it is for the moment. I'm just going to leave that as is. So if I needed to, if I were asked to find this in decimal form, then I'd go to the calculator and actually type that in. At this point, it's not my final answer, and it's not what I'm required to find as my end result, so I'll leave it alone. All right, now let's look at the surface area. Surface area is 2 capital B plus capital PH. So 2 times 48 plus, and now we've got this quantity. Because that is a quantity, you want to put it in parentheses so that when it comes time to type it into your calculator, you can get all of that quantity multiplied by h. Remember, h was our 15, the distance between those 2 triangles. Once we have all these values in place, then it's a matter of typing it into the calculator appropriately. So in this case, we'll type it in just as it appears, 2 times 48 plus, now because this is a quantity, I want to put it in parentheses, 20 plus the square root of 208. And I'm going to close my parentheses twice, once because it opened it here for the square root, and once for that quantity that I opened up initially, times 15. And we find that we get 612.33. In this case, this is an area, so our unit squared. And that becomes our surface area. Now for the volume. Volume is equal to the area of the base times the height. In this case, the area of the base is 48 times the height, 15. So 48 times 15, 720 millimeters cubed. And that is the volume of this particular solid. It would be my advice that you pause the video at this point and attempt this second example on your own, and then come back and check yourself. All right, so you've had some time now to go back and attempt number 2. I've gone ahead and started that problem. So I've redrawn the base separate from the prism. I know that one leg is 10 units long, or 10 yards long, and that the hypotenuse of that triangle is 26 units long. So I use the Pythagorean Theorem to determine the length of the other leg. Now in this case, we get the square root of 576. 576 is a perfect square. It is 24 times itself. So the length of the other leg is 24 units. For the area of the triangle, the capital B, take 1/2 times 10 times 24. Remember, these are the two values that meet at the right angle. So the area of the base is 120 square yards. And then I found the perimeter of the base to be 60 yards by adding those lengths all together. All right, so for our surface area, we take 2 times the area of the base, 120, plus the perimeter of the base, 60, times the height of the solid. And I haven't yet identified what the height of the solid is, but I know that it's the distance between the two bases. So the distance between this triangle and this triangle would be the 17 yards. So H is 17. Let the calculator do some magic for me. 2 times 120 plus 60 times 17. 1,260 yards squared. Now for the volume. Volume is the area of the base, 120, times the height of the solid, 17. In this case, 2,040 yards cubed becomes the volume of this triangular prism. And that takes care of finding the surface area and volume of a triangular prism when the base is a right triangle.